In this lesson, we're going to learn how to graph functions using reflection about either the x-axis or the y-axis. So let's look at this. So we can reflect a graph over the x or the y-axis. And let's talk about what a vertical reflection is, and then we're going to talk about what a horizontal reflection is. So we have a vertical reflection and something called a horizontal reflection. So a vertical reflection reflects a graph vertically across the x-axis. So let's look at what that means. So remember, vertical. So remember, vertical means going up and down. All right. So you're going to reflect it about the x-axis. So that's a vertical reflection. So let's look at an example. And it's a very simple process. The idea is simple. The concept is very easy to understand. So let's suppose we had this function right here. So there's the graph of f of x, and I want to conduct a vertical reflection of this function right here. So remember, a vertical reflection is a reflection about the x-axis. So I'm vertically reflecting it about the x-axis. So remember, here's the x-axis, here's the y-axis. And so basically what's happening is this. I'm going to go ahead and use a different color. And so every point, see how, now this is an easy graph to reflect because it's just segments. Well, this is a segment, this is a ray. But, um, but basically you're going to take every point on this part of the graph, see this horizontal segment, and you're going to reflect it about the x-axis. So when you're reflecting about the x-axis, just notice the distance from this point to the x-axis over the x-axis. So you see how this distance here is 2 units. So when reflected about this point about the x-axis, that distance right here is 2 units as well. Okay? Same thing here. If I take this point here, reflected about the x-axis, the distance from this point to the x-axis is the same as the x-axis to the reflection. So there's that point, and the same thing here. Okay? But here's what I want you to notice. I want you to know something. So there's a particular property about reflection about the x-axis. So if I look at this point right here, I'm going to call this point, and I'm going to go ahead and do that here. I'm going to with the blue color. So I'm going to call that point right here. This point is negative 5, 2, right? Negative 5, 2. But when I reflect it about the x-axis, I want you to notice what point this is. So this is a point negative 5, negative 2, right? And let's look at this point right here, this point that I reflected. So this point here, right here, that's negative 3, 2 in it. Negative 3, 2, right? And so when I reflect it about the x-axis, it becomes the point negative 3, negative 2. So what I want you to notice is this. When you reflect a graph across the x-axis, so when you do a vertical reflection, so when you do a vertical reflection, which is a reflection about the x-axis, I want you to notice about these coordinates. So negative 5, 2 becomes negative 5, negative 2. Negative 3, 2 becomes the point negative 3, negative 2. So notice the x coordinates stay the same, which is obvious because you're still at negative 5, you're still at negative 4, you're still at negative 3. But the y coordinates become opposites. 2, negative 2, 2, negative 2, and so on. So for example, if I look at this point right here, this point here is the point 2, 4, right? 2, 4. So when I reflect the point 2, 4, when I do a vertical reflection or when I reflect it about the x-axis, 2, 4 becomes what point? Think about it real quickly. It becomes what point? It becomes the point 2, negative 4, doesn't it? 2, negative 4. So that'll be, let me use an orange color. So that'll be 2, negative 4. So that's the idea of that reflection about the x-axis. So you reflect something about the x-axis, the x-coordinate stays the same, the y-coordinate, the points are, for the y-coordinates are opposites. 4, negative 4. So this becomes the point right here, 2 comma negative 4, and so on. Okay? So a vertical reflection, and it's important to remember this, and you can always visually think about this. So visually think about reflecting a point vertically. So you reflect a point vertically about the x-axis. the x coordinate stays the same, the y coordinates are opposites. It's easy to visualize. All right, so let's go ahead and finish this graph. So then this point here is 2, 4, and then this point, let's use this one here, right here. So this point here is 5, 6. So if 5, 6 is on f of x, then when I vertically, when I do a vertical reflection, 5, 6 becomes what point? 5, negative 6, right? 5, negative 6, and that's, let me use the orange color. So 5, negative 6 is here. So 5, negative 6. And then all you do now is just draw your graph. So this horizontal segment becomes this horizontal segment. See that? Very simple, right? Very simple process. Becomes that horizontal segment. And then this ray becomes this ray right here when I do a vertical reflection. Don't forget that this is a ray though, so make sure you use that arrow, arrow, arrow. And there's the graph. So this so the orange graph reflects or represents rather, the orange graph represents the reflection of f of x about the x-axis. See how simple that is? Very simple. So one thing I want you to remember about this is with a vertical reflection of f of x, you're basically reflecting f of x about the x-axis. So that's what we mean by vertical reflection. The other thing I want you to remember is that when reflecting points about the x-axis, um, the the x coordinate stays the same, the y coordinates are opposites. Okay, so basically xy becomes x negative y. Okay, so xy on the graph f of x becomes x negative y on the graph of negative f of x. So basically, remember this is your y, right? So the y coordinate here, 6, becomes the opposite here. So negative 6. Okay? All right, so that's what I want you to remember about vertical reflection. All right, so that takes care of this part right here. So the vertical reflection. And let's look at horizontal reflection. So when you think horizontal, um, so let's look at this. So when you think horizontal, a horizontal reflection meaning going left and right, right? So this is a vertical reflection. So vertical reflection is across the x-axis. A horizontal reflection is across the y-axis. All right, so that's what you see here. A horizontal reflection reflects a graph horizontally across the y-axis. All right, so horizontally across the y-axis. So again, we're going to use an example to illustrate this. So let's suppose that this is my function f of x, and I want to conduct a horizontal reflection of this function. So horizontal reflection, remember, you're going to reflect all of these points across the y-axis. All right, so let's look at an example. So here's what I mean by this. So let's start with this point right here. See, this is the point for negative 4, correct? I'm sorry, 4, 4, excuse me. 4, positive 4. That's in the first quadrant, this point right here. 4, 4. So when I reflected about the y-axis, so horizontal reflection about the y-axis, all right, so notice this distance. So this point is 1, 2, 3, 4 units from the y-axis, right? So when reflected about the y-axis, the other point better be 4 units from the y-axis as well. 1, 2, 3, 4, right here. Okay, this point here, which is let's see, that's 8, 5. Let me use blue. So that's a point 8, 5 right here. So 8, 5. So that is 8 units from the y-axis. So when reflected about the y-axis, this right here better be 8 units as well. 1, 2, 3, 4, 5, 6, 7, 8. And what I want you to notice, are these coordinates right here. Just like we were with the previous problem, I want you to notice these coordinates. So when I reflect this blue point right here, 4, 4, across the y-axis, so when I do a horizontal reflection, 4, 4 becomes the point, 4, 4 becomes the point, negative 4, 4, right? Negative 4, 4. And then here, 8, 5 becomes the point, negative 8, 5. See that? Negative 8, 5. And so what I want you to notice is this. Whenever you do a horizontal reflection, I want you to notice something about the coordinates. So notice the y-coordinate stays the same. Kind of makes sense, right? Because those 2 points are horizontally the same. They're on that horizontal line right here. But the x-coordinates are opposites this time. 4, negative 4. Look at this one. These 2 points are reflected. 8, 5. 8, 5 becomes negative 8, 5. The y-coordinate stays the same, which kind of makes sense. And the x-coordinates are opposites, which kind of makes sense as well, right? 8, negative 8. 6, negative 6. 5, negative 5, and so on. All right? So, and then, oh, and by the way, see this point right here? Just to let you know. So see how this point here, which is 0, 3? So, you see it's on the y-axis, right? So a point that's on the y-axis, when I reflect it about the y-axis, it stays on the y-axis, doesn't it? Because remember, um, uh, a horizontal reflection, the y-coordinate stays the same, the x-coordinates are opposites. So what is the opposite of 0? Well, the opposite of 0 is still 0, isn't it? Okay. So let's look at this point here, right here, though. See this point here? Negative, negative 2, 0. So when I reflect it about the, remember this is 0 right here. I'm going to make it a little bit better. So when I reflect that point about the y-axis, remember the y-coordinate stays the same, the x-coordinates are opposites. So 2 units, 2 units here. So that becomes the point 2, 0, doesn't it? Okay, 2, 0. And then let's do this point here, since those are segments. So those are easy to draw. This point here is negative 6, negative 6, negative 6, negative 6. So when I reflect it about the y-axis, so when I do a horizontal reflection, negative 6, negative 6. So remember, when you do a horizontal reflection, the y-coordinate stays the same as the x that are opposites. So here's my x-coordinate right here, negative 6. Now I'm pointing to this one here, x, y, x, y. So that becomes the point 6, negative 6. So 6, negative 6 is here, okay? All right, so then when I draw this, I get this. So let's go ahead and draw this orange graph right here, and I get something that looks like this. All right, so let me go ahead and align those points, make it look a little bit better, and so that's what I get. So the blue graph and the orange graphs are reflections of each other about the y-axis. Kind of makes sense. You see how this right here is symmetrical about the y-axis, and then the blue and the orange here are symmetrical about the y-axis as well. Okay, so a horizontal reflection of f of x, what I want you to remember here is this. A horizontal reflection is a reflection, so it reflects f of x about the y-axis. Okay, so reflects f of x about the y-axis. When reflecting points about the y-axis, all right, so when reflecting points about the y-axis, the x-coordinates are opposites, right? The x-coordinates are opposites. The y-coordinate stays the same this time. Okay, so in other words, xy on the function f of x becomes negative xy. Okay, so it becomes f of a negative xy. All right, now listen carefully. So remember a while ago I did this right here, um, f of x and then the opposite of f of x? Because remember, f of x is the same thing as y. And so here I'm taking the opposite of the opposite of y here, right? So that becomes the opposite of y. Over here, and this is important, the notation is going to be important. Here, though, so f of x becomes, so when I do a horizontal reflection, f of x becomes, now remember, x, negative x, right? So that becomes f of negative x. So that's what it becomes. So whenever you see f of negative x, that means that this is a horizontal reflection. When you see this right here, the opposite of f of x, that means that's a vertical reflection. So the opposite of x is a vertical reflection. F of negative x is a horizontal reflection. That's a horizontal reflection. Okay? All right. Now, let's look at this next idea. All right, so let's look at this. So we're going to go ahead and graph f of x, which equals, and let's say the square root of x. All right, so let's go ahead and graph this. So remember, when graphing the square root of x, just a reminder, and let me go ahead and do that here. So in graphing the square root of x, so f of x or y equals square root of x. So remember, I can only take the square root of a positive number 0. So keep that in mind. So when x is 0, the square root of 0 is 0, right? When x is, and I'm going to use perfect squares here, so I don't have to deal with decimals. When x is 1, the square root of 1 is 1. When x is, let's say, 4, the square root of 4 is 2, right? And then when x is, let's say, 9, a perfect square, the square root of 9 we know is 3. And so when I plot those points, I'm going to go ahead and use a colored marker here. So I don't know how thick that's going to be. But here's 0, 0. Here's 1, 1 right here. Here's 4, 2. And then here is 9, 3 right here. So when I draw the graph, this green graph, hopefully it's green. You can see it as green. So this green graph is the function square root of x. And remember, that's the parent. That's what we call the parent function as well, right? Square root of x would be considered a parent function. So remember, I'm using the word parent function. All right, parent function. So we talked about that in a previous lesson. Okay, what I want to do though now is I want to reflect this graph about the x-axis. So I want to do a horizontal reflection here. All right, so remember what a horizontal reflection is. So in the previous problem, we saw this. So we saw that I didn't mean a horizontal reflection, I mean a vertical reflection here, vertical reflection. So when we did a vertical reflection, remember that's the opposite of f of x. So what I'm going to do here is I want to graph um, the opposite of f of x, and we're going to call that g of x. I want to graph a new function called g of x, which is going to be the opposite of f of x. All right, so remember, f of x is y, right? So basically, you're taking the opposite of each of those y values. That's what you're doing. So this says you're gonna take. So this is y right here, right? That's your y. F of x means the same thing as y. So you're gonna take y's. You're gonna take the y coordinates of each of those points here, and you're gonna look at its opposite. So meaning you're going to reflect it about the x-axis. So that's that vertical translation. All right. So when I do that, so basically g of x then, right here, g of x becomes the opposite of, remember f of x is the square root of x, right? So g of x becomes the opposite of the square root of x. F of x is the square root of x. So that's what you're graphing. Now, I don't want you to use a t-table on this. Don't use a t-table on this. I want you to remember that basically what you're doing is you're you're taking the opposite of each of those y coordinates. So in other words, 1, 1, remember this is 1, 1, right? 1, 1 becomes the point 1, negative 1. 0, 0 stays 0, 0. 4, 2 becomes the point when I do a vertical reflection. That becomes the point 4, negative 2, right here. And then 9, 3 becomes the point 9, negative 3. And so now when you graph this, I'm going to go ahead and use the blue color here. So when you graph this, and do the best you can with graphing this, just make it look pretty good as best you can. You have an eraser. You're doing this with a pencil in your case, so you're able to erase to make it look a little bit better. So there's this right here. And I guess they both look the same color, but this is green, this is blue. So this here is the graph of g of x, which is negative square root of x. Okay? So basically what you did was you took f of x and you did a vertical translation. So basically you took all these points here and you reflected it. I meant not a vertical translation, a vertical reflection, excuse me. So vertical reflection. So you took all these points here and you reflected about the x-axis. So that's negative f of x. All right. Now what we want to do now is I want to take that green graph and I want to reflect it about the y-axis. So that's a horizontal reflection. Horizontal reflection. So remember, this is this right here is this right here. Remember, it's a vertical reflection of f of x. That's what g of x is. So this right here is a vertical reflection of f of x. What we're going to do now is we're going to look at a horizontal reflection. So remember, horizontal reflection. So this is f of x. I'm hoping you remember this from our previous example. A horizontal reflection, remember the y coordinate stays the same, the x coordinates are different. So f of x becomes f of negative x. So the x coordinates are opposites. Okay? X, negative x, x, negative x. So when I ask you to graph the horizontal reflection, you're basically graphing this. So you want to graph, and let's call this h of x, which is going to be f of negative x. That's what you want to graph. So f of negative x. And when you graph f of negative x, in this case, f of x is square root of x, right? So remember, and just let me go ahead and remind you of this. So watch. So this is f of x right here, square root of x, and in a previous lesson you knew how to find f of negative x. So remember, f of negative x is where we see x, you substitute negative x, right? So now what you want to graph is square root of negative x. That's what you want to graph. So h of x is going to equal, remember we're doing a horizontal reflection. So h of x will equal f of negative x, which is the square root of negative x. So when I did the vertical reflection, f of x equal square root of x, when I did the vertical reflection, g of x would be the opposite of f of x. So opposite of square root of x. Horizontal reflection, you want to, if this is f of x right here, and you want to do a horizontal reflection, you're going to find f of negative x, which is what this is, square root of negative x. So basically your y coordinates will stay the same. It's your x coordinates that will be opposite. All right. So f of negative x is a horizontal reflection about the y-axis. So remember that. So this right here is a horizontal reflection about the y-axis. So just like in our previous example, whatever point you see here, you're going to reflect it about the y-axis. So the y coordinate stays the same, the x coordinates become opposites. So in other words, I'm going to go ahead and use orange here. So the point 1, 1 becomes a point negative 1, 1. 0, 0 stays 0, 0. The point 4, 2 becomes a point negative 4, 2. Negative 4, 2. Okay? The point, and this was 9, 3 right here. The point 9, 3 becomes the point negative 9.3, right? Negative 9.3, which is right here. And so when I graph this, I get this graph right here. Oops, I didn't do this very well. So so if you had an eraser, you'd erase this little part here. So notice these two pieces here are a reflection about the y-axis, and these two pieces here are a reflection about the x-axis. Okay. All right. So f you have f of x here. So whenever you see negative f of x, right here, whenever you see negative f of x, that's a reflection about the x-axis. When you see f of negative x, that's a reflection about the y-axis. Now, I just want to remind you about this. So just to show you that the square root of negative x right here is actually this orange graph. So let me show you why that's true. All right, so suppose you want to graph this. So suppose you want to graph y equal square root of negative x, okay? And we're going to use the t-table just to show you that this right here is actually correct. So remember, I can only take the square root of a positive number, right? Positive number. So in other words, if x is 0, I have the square root of negative 0. But remember, negative 0 is still 0, correct? Which is 0. But what I want you to notice, though, is you cannot use 1. You cannot use any positive number here. You can't use any positive numbers. Any positive numbers. Because if you use any positive numbers, let's say 1, 2, 3, all those are negative. Negative 1, negative 2, negative 3. And the square root of a negative number is that imaginary number. It's not a real number. So your x's have to be negative. So for example, negative 1. I can, if x is negative 1, I can take the square root of the opposite of negative 1, because look, so if x is negative 1, look at what you have. You have the square root of the opposite of x. The opposite of x. But x in this case is negative 1, right? But what is the opposite of a negative 1? The opposite of negative 1 is a positive 1, and the square root of a positive 1 is 1. So when x is negative 1, you get positive 1. Let's do negative 4. When x is negative 4, I'm taking the square root of the opposite of a negative 4. So the square root of the opposite of a negative 4. Well, the opposite of a negative 4 is a positive 4, and the square root of a positive 4 is 2, right? And so that's what you see here. So look, negative 1, 1, right here, negative 1, 1. See that? Let me go ahead and write that out. So that right here is negative 1, 1. And then you see right here, negative 4, 2. That's what this is right here, negative 4, 2. Okay? All right. So that's the idea of reflection, horizontal reflections and vertical reflection. Okay? Horizontal reflection and vertical reflection. All right. Now, here's something else I want to remind you about, and that's this. All right. So, given a function f of x, all right, given a function f of x, if, let me write it this way, g of x, which is this, all right, so this, if you have a function f of x, and all of a sudden you're told g of x is equal to this, remember what this means. This means the opposite of y, right? So the opposite of y. So when you talk about the opposite of y, think of the coordinate plane. It's usually easy if you visually think about this. So when you think the opposite of y, so for example, this is 4 right here. This is 4 right here. The y value is 4. The opposite of y value 4 is a negative 4. So that's a reflection about the x-axis. That's a vertical reflection. It's always easy to think about this visually. So that's a reflection about the about the x-axis. So g of x equal the opposite of f of x is a vertical reflection. Vertical reflection about the x-axis. Okay? Vertical reflection about the x-axis. All right. If you have this, if you're told g of x is this, so f of negative x. So x, negative x. Look at it this way. The x's are opposites, right? X, negative x. So the x's are opposites. That means this. That means this. So think about it this way. So if you look at this point here, 2, 5, okay, and I reflected about the y-axis, it becomes the point negative 2, 5, right? So notice the x's are opposites. X's are opposites. So when you think of x's are opposites, that's a reflection about the y-axis. So that's a horizontal reflection. Okay, that's a horizontal reflection. All right, so g of x equal f of negative x is a horizontal reflection about the y-axis. Okay, so that's a horizontal reflection about the y-axis. Now, just to let you know, sometimes instead of saying the word about the y-axis, they'll say through the y-axis, something like that. Okay, um, so they'll say over the y-axis, through the y-axis. So sometimes they'll say over the y-axis, through the y-axis. So it's not always the word about the y-axis. You could say over the y-axis, through the y-axis. Same thing here. Okay, so be over the x-axis, about the x-axis. I'm sorry, through the x-axis. So over the x-axis, through the y-axis. So it's not always the words about the x-axis. All right, so let's look at one more example before we end this lesson. All right, so let's look at f of x. So let's suppose f of x is this function that you see, the graph of the function that you see. And let's suppose we want to graph, all right, we want to graph this. All right, so we want to graph g of x, which equals, and let's call it, let's do this. Okay, so whenever you see something like this, you have to remember this. See how remember f of x is y, right? So now you're going to take the opposite of y. So whenever you see that, you have to recognize right away. You have to recognize right away that that's a. So remember the y's change, right? So you have to recognize right away that that's a vertical reflection. Okay, so the y's are opposites. Let's say that the y value here is 8, then becomes negative 8. Okay, so the y values are opposite. It's a vertical reflection. So basically, you're going to reflect f of x about the x-axis. Okay, so let's go and do that. So I kind of darkened some points here. So I want you to notice is that this point here, and let's go ahead and label it. So that point here, which is for -5. So remember, if you're gonna do a vertical reflection for -5, becomes the point for +5, right? All right, so let's go ahead and do that. So that's gonna be an orange. So for +5, right here. Okay, and then this point here, right here, that's the point 6, -3. So whenever you're doing a vertical reflection, 6, -3, from a vertical reflection becomes the point 6, +3. So you're going to plot the point 6, +3 right here. 6, +3, and this was 4, 5. Okay? And then right here, see this point here? That point is 8, 2. So whenever I do a vertical reflection, 8, 2 becomes what point? 8, 2 becomes the point 8, -2, right? So 8, -2 is right here. 8, -2. And then over here, this point here, see how simple this is? It's not difficult. This point here, right here, is 2, -3. 2, -3. So 2, -3, when I reflect it about the x-axis, so when I do a vertical reflection, 2, -3 becomes a point 2, +3, right here. 2, +3. And then over here, this point here, which is 0, 2, when I reflect that point about the x-axis, 0, 2 becomes 0, -2, right? 0, -2. And then here's the, so the f of x is that blue graph right here. So when I graph the opposite of f of x, so when I graph g of x, which is the opposite of f of x, it's going to be this orange graph. So it's a reflection about the x-axis. And I want you to do the best you can with making this a good graph. So let's see, let's go on this side. You have an eraser, so you're doing this in pencil. So just erase and redo it if you have to. And you get something that looks like this. Okay, so notice the blue and the orange are reflections about the x-axis. See this? This is easy to see right here, right? So you take that blue graph reflected about the x-axis, you get this orange graph. Take this little piece right here. See that? Take that little piece right here, reflected about the x-axis, you get that piece. See that? And then this little piece here, reflected about the x-axis, you get that piece. Okay, so it's important to understand that if f of x is this and you're graphing the opposite of f of x, that's a vertical reflection. So you're reflecting it about the x-axis. All right, so let's do this one now. So let's suppose in this example right here, same graph, but this time let's graph this one. So let's go ahead and graph. Let's go ahead and graph g of x this time, which is this. So remember the difference. So this says, you see the x's are the same. X, x, right? X, x. It's the y. So this is y. This becomes the opposite of y. Notice this one, the x's are opposites. X, negative x. So whenever x's are opposites, you think a horizontal reflection about the y-axis. Okay, so this is going to be a horizontal reflection. And so remember, horizontal reflection reflects f of x about or over or through the y-axis. Okay? All right, so let's look at those points again. So this point here, which is for -5. So when I reflected about the y-axis, so when I do a horizontal reflection, it becomes the point -4, -5. So -4, -5. Okay? So notice the y coordinates are the same, the x coordinates are opposites. This point here, right here, which is a point 6, -3. So when I reflect it about the y-axis, so remember that distance, same as that distance. In terms of coordinates, that means that the y coordinate stays the same, the x coordinates are opposites. So 6, -3 becomes -6, -3. See, and you take the opposite of x. So if x is 6, it becomes -6. So -6, -3. -6, -3 is right here. Okay? And this point here, which is 8, 2, 8, 2. So when I reflect it about the y-axis, it becomes -8, 2. So -8, 2, which is right here. Okay? So -8, 2. Now let's get this point right here. So this point right here is 2, -3, right? 2, -3. So when I reflect it about the y-axis, it becomes -2, -3. So right here. Okay? -2, -3. And then this point here, which is on the y-axis, isn't it? That's the point 0, 2. So since that's on the y-axis, it stays on the y-axis, doesn't it? Okay, and then there's your graph. Okay, so let's go ahead and do as best we can with drawing this. So kind of like this, like I'm doing it. So doing the little pieces, I guess, just like this. And you will notice that the blue graph and the orange graphs are a reflection about the y-axis. See that? All right. So important to remember is this. The important thing to remember is this. G of x equal the opposite of f of x is a reflection about the x-axis. And let me put this of f of x. And then over here, g of x equals f of -x is a horizontal reflection about the y-axis of f of x. Okay. All right. So that is, I believe, the lesson on graphing functions using reflections about the x-axis and about the y-axis.